So here's my 3, 4, 5 triangle, same poor, sad triangle, and here's my theta. And we know that the sine of theta, oh, that's gross, is 3/5. The cosine of theta we learned was 4/5. And the tangent was 3/4. So since sine and cosecant are reciprocals, the cosecant of theta, just flip the sign upside down. The cosecant is 5/3. It's the reciprocal of sine. Or hip over op. Hypotenuse over opposite. Cosine was adjacent over hypotenuse. Flip that upside down, and that gives you secant, or hypotenuse over adjacent. And cotangent is the reciprocal of tangent, or adjacent over opposite. So once you have sine and cosine, technically, you could get all the other 6. All you need is sine and cosine, and you can get all 6 of them. But you've got to memorize that relationship. So when you hear people say sohcahtoa, what they're referring to is, here's what they're referring to. Sohcahtoa. It's the world's worst camp. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Sohcahtoa. And then did your teacher in high school or middle school do bad jokes about yeah. Or the hypotenuse about the airplane ride and the.
Well, tell us.
I don't know what they are because I refused to tell them, but
I don't remember.
I mean they're out there.
No.
No.
No, I don't remember.
Well.
I vaguely remember learning it.
Harsh. All right, let's practice this. I'm going to give you another triangle for you. Weaver loves it.
You said love it.
Okay, let's do this. We'll do this all together as one. This is not going to be pretty numbers right here. So I'm giving you this, and that's all I'm giving you. And then I'm going to give you that this is theta up here. That little angle right there is theta. So here's my angle. This is my right triangle. I'm giving you 2 and 3, and that's all I have given you. And from that, you should be able to give me all 6 trig functions. But before you can start, what do you got to do? Yeah, you got to find the hypotenuse. Okay, so I don't have a third side, so if I don't have a hypotenuse, I can't do sine and I can't do cosine. So you have to find the hypotenuse. That's the Pythagorean theorem. 2 squared plus 3 squared is my hypotenuse squared. Four plus 9 equals c squared. So C is ugly. You'll have more ugly than you'll have whole numbers. Okay, so I use the Pythagorean theorem to find C. The Pythagorean theorem. 2 squared plus 3 squared equals this side squared equals C squared. 4 plus 9 was 13. That's not C, that's C squared. So I have to take the square root of it to find C. Okay, that's okay, because all we're going to do is put that in fraction form. So it's okay that it's ugly, but now I'm going to use those definitions. Sine is opposite, which is 3 in this case. I'm going to do that in a different color. I don't like that. Let's do purple. Sine is the opposite, which is 3, over the hypotenuse, which is square root of 13. And we have to talk about that in a minute, but we're going to get all these
You
first.
can't have square root
Correct.
over, yeah.
You can't have a square root on the bottom. So we'll have to fix that. But right now we're going to leave it like this and get all 6. And then we'll fix them. But yeah. So go through to your definitions, opposite over hypotenuse, adjacent over. Go through your definitions and get all the other 5 trig expressions. Pay attention to which one is theta. Theta is this angle here. First grade lunch where he has cup problems? Oh, yeah.
Cup problem, yes.
Cup problems.
Exactly what it is.
That's a little bit marks. I don't know how many do they have. Looks good. They keep ours locked all the time.
Oh, yeah.
Are all dorms always locked?
Yeah.
Yeah, unless you.
Always.
Hey, do you know when finals start?
Yeah, Friday the 5th.
Do you know what
So they
classes?
start on a Friday?
Do you know what days the classes, like for that Friday one? Really?
No. I know 10:10 classes Monday, Wednesday, Friday have a final from 10:30 to 12:30 that day.
On Friday?
Uh-huh.
What time?
10:30 to 12:30.
That's the
How
class
do we
it
find
is?
out?
That's when the class meets, yeah. It's online.
Oh, is it?
I'll show you.
You told me you literally like maybe during second
What would we do without the drama of these two? It would be.
So it's not there. Yeah.
Oops, that's not what I want.
Just a simple
Why did
question.
you ask him first?
Did you live there?
Give your root answer.
Yeah. She was like,
I'm gonna
"Wait,
put it up there.
Oh, you
Chris
are?
says,
Okay.
yeah.
Guess it's a good one.
I'm gonna just pull it
Yeah,
up.
I mean, I've seen that one and the second one.
Oh,
Yeah, okay. And then there's a third one too, something you ordered. Is there one too?
There's still three.
Yes.
Alright, what's my cosine?
Yeah, it's definitely better.
2 over the square root of 30.
2 over square, 2 over square root of 13. Tangent, 3 over 2. So once you have sine and cosine, you can just look at, here's my sine top number, here's my cosine top number. 3 over 2. Cosecant, flip that upside down. So you got square root of 13 over 2. Square, oops, over 3, excuse me. Square root of 13 over 2 and 2/3. All right, that's nice and easy. We got to talk about this. These two are icky. And the reason they're icky is because you cannot have a square root in the denominator. I don't know who decided that. It's silly to me. But it is a mathematical rule from way back in the day. Square root of 13, you can't have a radical in the bottom. So you have to do something called rationalize it. This is okay. You can have one in the numerator. You just can't have one in the denominator. So for a final answer for sine and cosine, leave it like this in the beginning because it makes it easier, for instance, to get tangent. And if tangent's easy, cotangent is easy. But then go back and change these two by rationalizing. Oh, that.